Hello everyone, today we're going to explore factorization, which is a very interesting and important topic. It can help us simplify lengthy algebraic expressions, and this finds applications in solving problems of various kinds. So let's get started with factorization of quadratic polynomials by splitting the middle term. Yes, so let's look at the question 2x squared plus 6x plus 4. Okay. So to solve this, the very first step that we're going to do is to take the product of the coefficient of x squared, that is 2 here, and the constant term, right, that is 4. So we know 2 times 4 is going to give us 8, right? Now we're going to try and factorize this 8, right? 8 is going to be either 8 times 1 or 2 times 4, right? Then we're going to look at these factors, okay? Here in 8 times 1, we're going to look at the factors 8 and 1 and see if their sum or difference is going to give us the middle term, which is 6x, right? 8 plus 1 is 9, 8 minus 1 is 7, or 1 minus 8 is minus 7. So no, none of that gives us the coefficient of x, 6, right? So let's look at the other set of factors, 2 and 4. 4 minus 2 is 2, 2 minus 4 is minus 2, so the difference doesn't work here. But 4 plus 2, yes, that is going to be 6, which is exactly the coefficient of x here. So let's write the next step, which is going to be 2x squared plus the 6x I'm going to be writing as 2x and 4x. Okay, 2x plus 4x and the coefficient and the constant term as it is, right? Now the sum of 2x and 4x, yes, they give us the middle term 6x, right? And their product, the product of the coefficients of x here, that is 2 and 4, right? That's going to give us 8. Right, which is same as the product of the coefficient of x squared and the constant term, right? Then from here we're going to consider the first two terms and the last two terms. Then I'm going to try and take something common out of the first two terms, 2x squared plus 2x, right? I can take 2x common. So when I take 2x common, I would be left with exactly x plus 1, right? Then I can go ahead and see 4x plus 4. From there, I can take plus 4, right? Yes. When I take plus 4 common, I'll be left with again x plus 1. And remember, our goal here is to make these two terms the same, right? X plus 1, after taking the common out, whatever we have left, that should be the same in both the cases. Because in the next step, we're going to be taking this x plus 1 common, right? When we take this x plus 1 common, we would be left with a 2x here and a plus 4 here, right? So yes, we have the factors x plus 1 and 2x plus 4 as the answer to the question 2x squared plus 6x plus 4. Moving on to our next question, which is 6x squared plus 7x minus 3. We have to repeat the same steps over again. Okay, first let's take the product of the coefficient of x squared, which is 6, and the constant term, which is minus 3, right? And 6 times minus 3, it is going to give us minus 18. Alright, now we have to go ahead and write down all the factors of minus 18. Let me do that. Minus 18 can be written as minus 18 times 1 or 18 times minus 1, right? Then we can write it as minus 6 times 3 or 6 times minus 3, and we can write it as minus 9 times 2 or 9 times minus 2, right? Now, if you're just getting started with factorization by splitting the middle term, you can go ahead and take the sum or difference of all these different pairs of factors, and at the end you'll understand that 9 times minus 2 or 9 and minus 2 are the desired factors. With a little bit of practice, this process of finding out which are the right pair of factors, it comes a little bit easier, right? So 9 times minus 2, right, is 9 and minus 2 are the desired factors. So we can go ahead and write the next step. Let me just clear this out. Yes, 9 and minus 2 are our desired factors, right? And now next step, we'll be splitting this 7x as 9x minus 2x, okay? 6x squared plus 9x minus 2x and the constant term as it is, minus 3, right? The difference of 9x and 2x is going to give us 7x, right? And their product, 9 and minus 2, that is going to give us minus 18, which is the same as the product of the coefficient of x squared and the constant term. Alright, then we have to consider the first two terms and the last two terms together. Taking common out from the first two terms, I think I'll be able to take 3x common and we'll be left with 2x plus 3, right? And then in the second set of terms, if I, our goal is to get 2x plus 3 on the other side as well, right? So we're going to take minus 1 common, right, from minus 2x minus 3, and we would be left with 2x plus 3, right? Now I have 2x plus 3 here and 2x plus 3 here. So let me just take 2x plus 3 common again, and the other factor would come out to be 3x minus 1. And yes, these two are the factors of 6x square plus 7x minus 3. Okay, here the product of the coefficient of x squared and the constant term, 2 times minus 15, it's going to be minus 30. There are different ways to factorize minus 30, but the one that we will be needing here is minus 10 and 3. Okay, minus 10 and 3 are the decide factors here, because minus 10 plus 3 is going to give us minus 7x, right? And notice that since the middle term is having a negative sign, the bigger number out of the two factors, the bigger number, which is 10, is having the negative sign, right? So let me go ahead and write the next step, which is 2x squared minus 10x plus 3x minus 15, right? From here, yes, minus 10x plus 3x is minus 7x, and minus 10 times 3 is going to be minus 30. Alright, then from the first two terms, that is 2x square minus 10x, what can I take common from there? Yes, that's 2x. If I take 2x common, I'll be left with x minus 5, right? And then from 3x minus 15, if I take a plus 3 common, again I would be left with x minus 5. So yes, these two terms are the same. Let's take them common out again, and we have 2x plus 3. Right? So the factors are going to be x minus 5 and 2x plus 3. The next question is 9x square minus 12x plus 3. Here, the product of 9 and 3, that is going to be 27, right? We have to factorize this 27 into two numbers such that either their sum or the difference is going to give us minus 12, right? What numbers would that be? It's going to be minus 9 and minus 3, right? A negative number times a negative number is going to give us positive 27, right? Positive number. But their sum, minus 9x minus 3x, right? That is going to give us minus 12x. Okay. So let's go ahead and write the next step. 9x square minus 9x minus 3x plus 3, right? Then we can take 9x common from the first two terms, right? So we'd be left with x minus 1. And then if we take minus 3 common from minus 3x plus 3, we would be left with x minus 1 again, right? If we just took 3 common, we'd be left with 1 minus x, which is not the decide number, right? Not the decide factor. So we would go with taking minus 3 common. Then from here we can take x minus 1 common again, and we have 9x minus 3. Okay, so these two are the factors. Here, the coefficient of x squared is going to be 1, right? And the constant term is 6. So 1 times 6 is going to be 6. So we have to split this 3 root 3x into two numbers, right? Such that their product is going to give us 6. Okay, so when I look at ways to split 3 root 3, I would see I can do it as 2 root 3x plus 1 root 3. That's root 3x, right? So let me see, 2 root 3x plus root 3x is going to give me 3 root 3x, and their product 2 root 3 times root 3, right? Root 3 times root 3 is 3, right? So 2 times 3 is going to give us 6, which is the decide product, right? So yes, I can split 3 root 3x as 2 root 3x and 3 root 3x. So let me go ahead and write that. X square plus 2 root 3x plus root 3x plus 6, right? From the first two terms, I can take x common, and I will be left with x plus 2 root 3, right? Then from root 3x and 6, if I take a root 3 common, I would be left with x plus 2 root 3. Now, how did this 2 root 3 come? Because 2 root 3 times root 3 would give us 6, right? Yeah. So from here again, we can take x plus 2 root 3 common, and we would be left with x plus root 3. And yes, these are the two factors, x plus 2 root 3 and x plus root 3. This question was slightly different because it had an irrational part, but the method just remains the same, right? The process is exactly same as what we've done in all the previous cases. I've tried to cover all the basic examples of factorization by splitting the middle term in this video. If you want to practice more, feel free to check out the questions that I've linked in the description box. Thank you for watching. See you next time. Bye-bye.